Question number 9a, we have to express 4x squared minus 12x plus 13 in the form 2x plus a whole squared plus b, where a and b are constants. So to convert this, we can first write the equation, which is 4x squared minus 12x plus 13 is equals to 2x plus a whole squared plus b. If we expand this expression, this will become 4x squared plus 4ax plus a squared plus b, and that is equals to 4x squared minus 12x plus 13. To find the value of a and b, we can compare the coefficients. So on the left hand side, the coefficient of x is minus 12, and the coefficient of x on the right hand side, that is 4a. So 4a will be is equals to minus 12, and a will be is equals to minus 3. The coefficient of the constant term on the left hand side is 13, and on the right hand side, that is a squared plus b. So a squared plus b will be is equals to 13. We know that the value of a is minus 3. So this will become minus 3 whole squared plus b is equals to 13. So b will be is equals to 13 minus 9. And the value of b will be is equals to 4. So we can write this expression as 2x minus 3 whole squared plus 4. In part b, it says that the function f is defined by f of x is equals to 4x squared minus 12x plus 13 for x greater than p and less than q. The function g is defined by g of x equals to 3x plus 1 for x less than 8. In part b, it says that given that it is possible to form the composite function gf, we have to find the least possible value of p and the greatest possible value of q. Now, the composite function gf basically means that in the function g, which is 3x plus 1, the x will be replaced with f of x. So this will be 3 into 2x minus 3 whole squared plus 4 plus 1. Now, as the function f is taking the place of x in the function g, and we know that the domain or the value of x for g is less than 8. So we can now write this as less than 8. So this will become 2x minus 3 whole squared plus 4, and this has to be less than 8. Simplifying this, we'll get 2x minus 3 whole squared will be less than 4. Taking the square root, we'll get 2x minus 3 will be less than. So the square root of 4 is plus minus 2. So this will be plus minus 2. Now solving this to find the value of p and q, which are basically the x values for the function f. So we can write it as 2x minus 3 will be less than positive 2. Taking 3 on the right hand side, this will become 2x is less than 5. So x will be less than 5 upon 2. So the value of q will be 5 upon 2. And to find the value of p, we can write it as 2x minus 3 will be less than minus 2. Taking 3 on the right hand side, that will become 2x. And as this is basically less than 4. So to understand this, we can write it as we have to find the value of p and q. So x will be greater than p. So the lower value in this case will be minus 2 plus 3 over here. So this will be 2x is less than 1 and x will be less than 1 upon 2. But as this is the lower value, so this will be the value of p. These are the two values of p that we have. The two values of x, the lower value is p. So in this case, p will be is equals to 1 upon 2 and q will be is equals to positive 5 upon 2. In part C, it says find an expression for g of f of x. Now we know that g of x was written as 3 into, so that was 3 into 2x minus 3 whole squared plus 4 plus 1. So first expanding the bracket, this will become 3 into, this will become 4x squared minus, or we can write the original function of f of x, which was 4x squared minus 12x plus 13. So this will become 4x squared minus 12x plus 13 plus 1. Expanding the bracket, we'll get 12x squared minus 36x plus, so 3 times 13 is 39 plus 1. Simplifying this, so the final answer for the expression for g of f of x will be is equals to 12x squared minus 36x plus 40. In part D, it says that the function h is defined by h of x is equals to 4x squared minus 12x plus 13 for x less than 0. We have to find an expression for h inverse. Now we know that this h function is basically the same as the function f, and we converted it to the form 2x minus 3 whole squared plus 4. To find the inverse of a quadratic equation, you always have to convert it to the complete square form. To find the inverse, we'll first write y is equals to 2x minus 3 whole squared plus 4. Now exchanging the values of x and y, this will become x is equals to 2y minus 3 whole squared plus 4. Taking 4 on the right hand side, we can write it as 2y minus 3 whole squared is equals to x minus 4. Now taking the square root on both the sides, so this will become 2y minus 3 is equals to square root of x minus 4. Now taking the 3 on the right hand side, this will become square root of x minus 4 plus 3. And finally, we'll divide the whole expression by 2. So y will be is equals to square root of x minus 4 plus 3 upon 2. Now, as the square root comes with a positive and a negative sign, and we know that the value for the function h, x value is less than 0. So it means that the range for the inverse function, now this is this inverse function, which is basically now h inverse of x, and we can add a positive negative sign over here. We know that this h inverse of x can be written as square root of x minus 4 upon 2 plus minus plus 3 upon 2. Now, as this also has to be less than 0, so writing h of x as it is less than 0, so basically the domain of h of x was less than 0, which means that h inverse of x will also be always be less than 0. So for it to be less than 0, this term must be a negative. For if this term is a positive, this whole term will become greater than 0. So the final answer for h inverse of x will be written as, so this will be 3 upon 2, and we'll take this with the negative sign so that it becomes less than 0. So the final expression for h inverse of x will be 3 upon 2 minus square root of x minus 4 upon 2.